skeletal muscles can move our body, like our arms and legs, for example, because they work in antagonistic pairs. Antagonistic muscles are muscles that produce opposite movements at a joint. So if you think of your elbow joint, like it's shown here, the bicep and the tricep are going to result in opposite motions at your arm, at that joint, when they are contracted. When the bicep contracts, it shortens, right? So when a muscle contracts, it shortens that muscle. And in shortening, it's like a rubber band pulling on your arm because that muscle is connected here via a tendon to the bone. Shortening the muscles pulls on that tendon, pulls your arm up. While this is happening, the tricep has to be relaxed. In contrast, when you need to straighten your arm, that's when we see that then the bicep will relax, the tricep will then contract and shorten, and when it does, it's going to pull on a tendon on the opposite side, on the back of the arm. And it will pull in this direction and extend your arm. And as a result, these muscle pairs can be thought of and referred to as flexors, the one that bends the joint, and extensors, the one that extends or straightens the joint. We'll see that there are proprioceptors in the muscles which provide information about the position of your muscles. Muscle spindles, they detect stretch, so they are found in muscle. So the name is actually really helpful. Muscle spindles are found in the muscle. They become activated when you stretch a muscle. They initiate reflexes that oppose activity in the antagonistic partner. So they don't actually do anything to the muscle that they're in, but they will send out a signal that is going to oppose activity in the antagonistic partner muscle. They help maintain posture and they respond to sudden changes. And we'll see that the muscle spindle is involved in your knee-jerk reflex, also known as the patellar reflex. There are also receptors, proprioceptors, in the tendons, Golgi tendon organs. They detect the amount of tension in a muscle. So they are reacting not when a muscle is relaxed or stretched, but when it's contracted and tight. And when that happens, it puts a lot of tension on the tendon. And so the tendon now is under a lot of tension. The Golgi tendon organs are going to react, and they are going to prevent the tendon from being stretched too much, and because that could end up damaging the tendon or end up damaging the muscle. So a Golgi tendon organ prevents us from over contracting a muscle, making too strong of a contraction that could potentially damage the muscle or the tendon because of the tension that it's under. Muscle spindles react when a muscle is extended and it's stretched out straight. Here is a short video that describes the patellar reflex.
Welcome to 2-Minute Neuroscience, where I simplistically explain neuroscience topics in 2 minutes or less. In this installment, I will discuss the knee-jerk reflex. The knee-jerk reflex, also known as the patellar reflex, is a well-known example of a simple reflex arc that allows us to maintain posture and balance. Most of us have had our knee-jerk reflex tested at a doctor's visit, when the doctor taps the tendon just below your kneecap, which is the patellar tendon, with a small hammer. This causes your lower leg to automatically kick outward. If this doesn't happen, or if it happens excessively, it can be an indication of a disorder or of damage to the nervous system. The knee-jerk reflex is a simple reflex arc that occurs at the level of the spinal cord. In other words, the associated movement occurs without the involvement of the brain. The brain receives information about the movement after it has been initiated. When the patellar tendon of the quadriceps muscle is stretched, the stretch is detected by stretch receptors known as muscle spindles that are found in the quadriceps muscle. The muscle spindles stimulate sensory neurons that travel to the spinal cord, where they synapse with motor neurons that control the contraction of the quadriceps muscle. These motor neurons cause immediate contraction of the quadriceps muscle to produce movement of the leg. The knee-jerk reflex is considered a monosynaptic reflex because it involves direct connections between sensory neurons and motor neurons without any neurons in between. Although the reflex is often simplified in diagrams to show only one sensory and one motor neuron, in reality the reflex involves many neurons. Stretching the quadriceps muscle activates several hundred sensory neurons, each of which makes contact with around 50 motor neurons. Additionally, the sensory neurons traveling from the muscle spindle to stimulate interneurons that inhibit the activity of motor neurons that supply opposing muscles like the hamstring muscle. The stimulation of these inhibitory interneurons causes the action of the quadriceps muscle to be unopposed.